So our next presentation, and we're now into the growth track rather than add insights, is how to boost your engagement in your game by supercharging your live ops with time-based machine learning. And that's with Davor here from Kaskada. Davor, I took a look at Kaskada's offerings. I have to say, my hat's off to you. Well, it's not, it's on. But really, really interesting stuff. So I'm really looking forward to this talk.
All right. Thank you for the kind introduction. So my name is Davor Bonaci. I'm the co-founder and CEO of Kaskada. And today I'll be talking to you about boosting engagement, personalizing the game through machine learning. And I want to start today with a story. It's a true story. A couple months ago, I was talking to a CTO of a gaming company, quite large, very accomplished executive. I think he worked on 5 or 6 different games over his lifetime. He's leading a large team. And you know what he told me about machine learning? That they were able to learn and build a model that is able to predict inside the game that the player will die the moment before they do. So what can you do with that? Obviously pretty much nothing. He went on further to say that kind of leaders in gaming, in particular, don't understand machine learning. That they only see skeletons of projects that really never managed to produce an impact, never managed to get to production, never managed to make an impact. It's a true story. But today I'll be talking to you that it doesn't have to be that way. And so let's start with something, that you have probably seen quite a few times. The promise of personalization in gaming. Oh, sorry. The promise of personalization in gaming. So, live ops platforms in particular talk a lot that you can do improve the monetization in a game by doing basic segmentation, advanced segmentation, event-triggered message delivery. You can get customized messages. All of these things should kind of give a lift to some income. And here on the kind of vertical axis, we see some promises that I guess some people have achieved. However, it is difficult. What we have observed by working with a lot of games is that the experience of doing that tends to look like a cockpit. There's so many options, and it's really hard and sometimes scary to turn these knobs. Because like we've seen, frequently, like 90% of the revenue comes from 5% of players. So if you press the wrong button, are you going to cannibalize some portion of it? And so, it's working now, so don't touch because we don't know what's going to happen, right? This is what happens today. This is why kind of it's difficult. But my point of view tends to be different. Today, we can predictably create and reliably operate time-based machine learning models that will effectively personalize the game, that will boost engagement, that will work. And in this kind of short talk, I'm going to talk a little bit about how we think and why I think this is possible today. So let's start with basics. I think there's all kinds of data in the world. People have built machine learning models, to recognize chairs in images, or to recognize faces, or do something with text. But there is one kind of data that in our case is really, really useful. And that is kind of event-based data that is coming from the game itself, right? Like the understanding that the player came, that they won, they lost, what they did, and how they did it, right? This event stream that at this point in time, something happened, this player did something, or clicked somewhere, or tapped somewhere. That data tends to be really, really predictive from which good models can be built. So let's start in building an understanding how can we achieve this. I think the first thing is to set realistic expectations and understand what is possible, right? Like oftentimes in well-monetized games, somebody cares about lifetime value of the player, and they want to predict obviously the lifetime value of the player so they can know what offerings to make. Is it possible to predict 365-day lifetime value during the first 3 minutes of play? Well, probably it's not possible, right? Like never say never, but it's probably not possible. Though it is probably possible to predict, 7-day engagement or, churn, it's probably possible. So it's really important to understand what kind of models can be built with what quantity of data, and have a clear expectations kind of as you are approaching this problem so that you know what to expect and what is possible. The second thing is kind of how to approach this problem. I think what many people do today is to do some kind of cohort and segmentation analysis of players. And so here on this slide, let's say that I have 3 groups of people, 3 cohorts, right? Like on the last group is like people that have bought something in the game. So that's kind of people that we have earned something from. The second category, like people that lost a bunch of times, never won. And then, first group, maybe that people won some number of times and lost some number of times. Maybe they post on social media some number of times. Right? This type of segmentation tends to be easy. You collect your data from the game, you count number of events, and put people in categories. This is not hard. But it turns out that it's also not particularly predictive. From this, we can frequently build models that tell us, how many people we're going to churn in the next 10 days. But it's really hard to predict which ones, because we have lost most of the interesting information inside this kind of analysis. So if we want to build models that work, we have to look deeper than just counting something over the entire period of time. So we want to build really good models, really good segments, so that we can personalize to those segments. We have to do something better. And it turns out that the features that will work can be figured out by lining these events on a timeline. So we have these same people from the previous slide, but they are no longer kind of segmented just based on the number of certain events, but kind of when you lay these events down on a timeline, we can start thinking about who they are and what is their motivation to be playing this game. So look at this third person here. When you lay down these events on a timeline, we see that this person really, really wants to win, right? When this person loses 3 times in a row or 2 times in a row, she tends to buy something in a game, and then she loves to win afterwards. The second player have lost a bunch of times, and then posted on social media, which probably was not a super good post, right? And then this first player is posting on social media every time after they win, right? So we know a little bit about their motivation, and so we can reason about what they are doing and how they are doing it, at what time they are doing it. And we start expressing features in this way about our players and feed it into the reasonably simple machine learning models. These models start to work. Right? When we look at gaming data and collect these types of events, when we build the right features, now these models tend to correctly predict what's going to happen. And why they work? They work simply because the people in the future tend to behave very similarly to people in the similar situations in the past, right? And we have enough information about statistically how something happens in the past, and we can clearly kind of map them to the right motivation, to the right group, that the model tends to correctly predict what is going to happen. And this is how we can build these models, and they tend to work. They just, tell the future with a really high probability. In the interest of time, I'm going to skip that. But it's not only the features. It's really important in your game to figure out at what points in time to make a prediction, right? Like, here is like a timeline that we've frequently seen, right? Like what can we do when the first session start? When the player misses and has not played for a day, like missed, every missed day, what happens after losing a level? What happens when they get stuck, right? Like, and this last one, particularly like the moment they spend their first dollar in the game, tends to be a really, really interesting point. And by that time, we tend to know a lot about the player to be able to correctly predict their lifetime value. But it's hard to generalize. It really happens that, demographics of every game tends to be slightly different. Motivations, why they are playing the game tends to be slightly different. Times that they are playing the game tends to be different. And so this analysis really has to be done on the gaming data inside the game to discover that for your audience, for your game, at the right points in time, the right signals give prediction about what's going to happen. And then the models tend to work. Then the game can be really effectively personalized. But it's not only, this is kind of the theory of how these models, how we have found these models to work. But we also need software to be able to do it. And then this is again a slide that you may have seen, many times from many different companies, which say, you get your raw data, then you do some feature engineering, then you build some models, and then you put models in production, and then the life is, cool, and this is super easy. Well, the reality is it's also more difficult than this slide says. It is not this easy. Really, the process for understanding and learning these things in your data, understanding what are the key points in time in your journey of players, tend to be like, a little bit more complex, manual, and frustrating. What often happens is, eventually it starts working, but oftentimes there is a lot of pain along the way. You need to collect all of the data in the right way at the right points in time. You have to build those scalable infrastructure. Sometimes we miss some collection times. Then there needs to be some pipelines that are moving it from place to place, cleaning it, or doing something else with it, right? Like, aggregating in different ways. Like this tends to take time. And even when it seems to work the first time, then we discover that somehow we have introduced temporal leakage and it doesn't work again. And that's why, like, people have found out that it takes 18 months to do anything. And that's the source of the CTO level comment that I started this presentation with. This is the difficulty of getting it done. But again, my point of view is it doesn't have to be this way. It can't, like, so much investment has been done over the last, few years that it doesn't have to be this way. So how do you know that you are in this world where, you have started thinking about monetization and growth, you have invested in live ops platforms, you have started using it, you have built a few things, you have, even started thinking about, data science work, right? These are some of the indicators, kind of from a management standpoint, I guess, what happens when we are not doing this well. Not surprisingly, I lead one of the companies that is, building data infrastructure to support this type of work. And we focus on iterative time-based feature engineering, which is kind of iteratively finding out what are the right points in time and what are the right features that make these models work. And so we tend to focus on feature engineering and sharing and discovery, and we focus less on the getting to production part. Obviously, there are other great companies in the space that can help with other parts of the process. But what we do, what we have found, particular success is around finding these points in time and the right features in the gaming vertical. Finally, I'm just going to talk a little about the case study that we have done with a mobile gaming company at the end of last year, right? In this specific case, it was a mobile game. It was more like a casual game in this specific case. And they really they really wanted to uh, they really wanted to improve day one retention because they were kind of significantly below industry average. They started this problem, more than a year ago, and very little progress was done. Very little progress, because so much work needs to be done to understand what's going on, right? And then, you don't have much choice as a leader of this type of organization. Like, you have to do it, right? If you are losing too many players on day one or day seven, just you are losing too much on your funnel, and it's difficult. And so we came, and in 2.5 weeks, we built 8 models, and the results were off the charts, right? And I think that is the timeline when, after the data is collected, in a few weeks, I think it's possible to understand what's going on in the game, understand the pinpointing the path of success, and understanding what levers to pull in a live ops platform to make it work. All right, and then so finally, kind of in terms of a conclusion here, if you're interested in these types of problems, stop by our booth over there. I would love to kind of understand the more details about your game, and we can kind of do a little bit deeper analysis of what features you are currently using, building, and see, can we talk about it and use some of our examples from other games to give you some ideas of what might be predictive. Thank you.
In the absence of a slide, I was just wondering, does anybody have any questions for Davor about machine learning and about how that can help within your games? I have one. Do you find that when you're talking to, like in the last mobile game that you worked with, how easy was it for them to identify those points that you needed to come in and do the data analysis on?
Yeah, it's very hard. We have an intuition, right? Like a person who built the game tends to have an intuition why the people are there and what happens, right? Like, you probably have an intuition that the player shouldn't win all the time, or that it's going to be boring. Shouldn't lose all the time, right? So there is some intuition that there should be the right fraction of wins versus losses. But where is that fraction? Tends to be very difficult. Is it the same for everybody? Is it the same for people with the same motivation? Right? And we tend to, as a leaders and builders of games, tend to think about it, most people like us. So if I would like to win 80% of the time, then maybe the world would like to win 80% of the time. It turns out that's not the case. There are some people who actually stay engaged much longer if they win only 20% of the time. Right? And so understanding the people, their motivation, and being able then to build a really quality game that's engaging and fun, I think that's what we are all about.
Yes, absolutely. Thank you, Davor. Anybody else? Yes, there's some more questions over here.
Thank you. I'm just wondering if there are any particular genres or styles of game that lend themselves better to using this machine learning sort of model to segment users in this way.
Yeah, I think it applies to all genres. I think the impact tends to be bigger the more wider the audience is, right? So we've seen some number of games that have very niche audience. There it is harder to make an impact. The wider the audience, the people tend to be widely different, and the impact is bigger. So, so more, if the game is more casual, appealing to more people, the impact is bigger.
Thank you. And we had that gentleman over there.
Hi, so how many cohorts do you usually need, and what's the sample size to kind of build a viable model before you can say this is stable?
I mean, that depends from game to game. We usually start with no more than 5, right? Like, you start with 5 and see where that gets you, or even less than 5, right? You saw in the slide, there's 3 groups. right? The start is small. And then, depending on the resources available and the results we see, it can increase a lot. We've seen dozens, but usually start with 3, 5, something. But normally it can get very high. Obviously, the lift from 30 to 40 will not be that big. Lift from 0 to 10 is going to be very big.
Great. Super. Well, thank you very much, Davor, again. And sorry about the technical.
No worries.